Assalamualaikum and hi everyone. So we will be looking at our chapter 1 here for SP015. Chapter 1 is on physical quantities and measurements. So today we'll be doing chapter 1.1, dimensions of physical quantities. There are 3 learning objectives that we have to obtain by the end of the session. The first one is to define the dimension, to determine the dimension of derived quantities, and to verify the homogeneity of equation using dimensional analysis. So first we are going to look at the first learning objective, which is to define the dimension. Okay, what is dimension? Dimension is defined as a technique or method used to describe the physical quantities in terms of basic quantity. So it's a method where you use to describe the physical quantities back to the basic quantities. Okay, and then a bracket, this type of bracket, a sharp end, will be often used to denote the dimension of a physical quantities. So to associate any dimension, we use this type of brackets here. Alright, for an example, let's say you have a mass. Okay, so the dimension of mass is either written as bracket mass or bracket small m close bracket. Or you can also just associate the symbol with dimension, where the symbol for mass is m. So you use capital M here to associate dimension. So there are 3 methods or 3 ways to write your dimension, where you use the bracket, you write your quantity inside, or you associate it with the symbol here. Alright. However, pure numerical factors or numbers such as 1, 1/2, pi, all these terms does not have any dimension. They are dimensionless. Okay, numbers do not have a dimension. We can only associate physical quantities to dimension. Okay, so let us now look at dimension of basic quantities. We know there are 7 basic quantities. The first one is length, time, mass, electric current, temperature, amount of substance, and luminosity. Okay, so let us write a few of these examples here. Let's say we have length. So our basic quantity here is length. So let's say if I want to write the dimension for length, I can either write length with a bracket or bracket L, small l, or I can simply write the symbol L as my dimension. Alright, besides that, let's say if you were to write dimension for time, time has a dimension of bracket time or bracket T. You do not write the unit. The unit for time is second. For dimension, you do not use the unit. You use the symbol for basic quantities or the capital T. These are a few examples. Okay, so you can deduce for the rest of your basic quantities, or you can refer to our notes. Alright. Okay, dimension can be treated as the algebraic quantities through the procedure of dimensional analysis. Okay, so basically what is dimensional analysis is, it is a procedure by which the dimensional correctness of an equation can be checked. Let's say if you have an equation, you want to check the equation is correct or wrong, you can use the method of dimensional analysis to check the correctness of an equation. So there are basically 3 uses of dimensional analysis. The first one is to determine the unit of physical quantity. Next is to derive mathematical expression or equation. And finally is to check the correctness of a physical equation by using the principle of homogeneity. Alright, so the first uses here, which is to determine the unit of physical quantities, this one will cover our second learning objective that I've mentioned at the beginning of our lesson here. The second learning objective is to determine the dimension of derived quantities. So by using this dimensional analysis method, you can actually come out with the derived quantities unit as well. Okay, so for an example, we have our physical quantities here. Let's say I'm going to choose any of the derived quantity here, which is not the 5 basic quantities that we have. So let's say I choose a velocity. So velocity here, we know velocity is a derived quantity which comes from the formula of displacement over time. Okay, displacement over time. So we have velocity is displacement over time. I'm going to now find the unit for velocity. What is the unit for velocity? Alright, so I'm going to use the method of dimensional analysis. So this is how you're going to do. So you know velocity, the dimension of velocity is, you can either spell it out, velocity with a bracket, or you can also use the symbol V here. Okay, is equals to, since the velocity is in dimension, therefore I'm going to change my equation displacement over time here into dimension as well. So my symbol for displacement is S, and symbol for time is T. So they are written in terms of dimension. Alright, so as displacement here is not a basic quantity. So in terms of basic quantity, it is basically the length. So dia adalah length, kita ukur panjang. Displacement is basically you're going to measure the distance, kan, jauh kan. Alright, so we are going to associate it with the basic quantity here, which is the length here. So this is my length here, and then dimension of the time here. Alright, so next I'm gonna simplify this into, this is already the final answer basically, but I want to write the symbol for dimension such as the capital letter. I don't want to use the bracket to make things looks less messy with too much of brackets here, because this is also another method of writing dimension. So I managed to get the dimension of velocity such as LT -1. So L here is actually the mass. L here is the mass and T here is the time. So what is the unit for mass? Mass lah pula. Sorry ya. Length. Okay, L is the unit for L here, what was I talking tadi? Lagi sekali, come on, again. You can do this. So L here is basically length. So the unit for length here is meter, and T here is actually time. So the unit for time is second. So from here I can get the unit for my velocity, which is ms -1. So can you see the use of dimensional analysis here? Alright, next we are going to look at to check the correctness of physical quantities by using the principle of homogeneity. Okay, this is ini yang paling banyak lah kita guna. Okay, usually kita guna dimensional analysis is to check the homogeneity of a equation. Maksudnya kita nak tengok sesuatu equation itu correct or wrong. Kita nak tahu dia betul ataupun salah. So we use the principle of homogeneity to check the correctness of the physical equation here. Alright, so before we look at the principle of homogeneity, kita faham dulu apa maksud homogeneity, which come from kata dasar dia homogeneous. Alright, okay, homogeneous. When we are talking about homogeneous, basically what are we trying to do here is a physical equation is said homogeneous if the dimension of all the term in the physical equation are the same. Okay, kalau semua term dalam sesuatu physical equation adalah sama, kita panggil dia homogeneous. Alright, and this homogeneous, or to check the homogeneity, okay, it actually involves checking the dimension on the left hand side LHS and the right hand side RHS of the equation. Alright, so basically selalunya when you have an equation, kita akan ada something written on the right is equals to something written on the left. Kita akan ada dua bahagian untuk setiap equation. So yang belah kiri ni kita panggil left hand side lah, LHS. Yang belah kanan ni kita panggil right hand side, RHS. Okay, so what are we trying to say here is, if the dimension di belah kiri sama dengan dimension di belah kanan, maka kita akan cakap the equation is correct. To check the correctness of a physical equation, sebab they are homogeneous. Bila kiri dan kanan sama, kita panggil dia homogeneous. Kalau homogeneous, maka equation itu tepatlah. We can make that conclusion dekat sinilah maksudnya. Sebab kita dapat identify that the equation is dimensionally correct. Secara dimensional, the equation is correct. Okay? Alright. So, the left hand side is equals to right hand side means the dimension sahaja. We are talking about the dimension sahaja kena sama. Okay, let's say you have an example of equation S is equals to UT plus half AT square. This is half AT square. This is a kinematic equation. Okay, ini adalah equation yang kita akan jumpa dekat chapter 2, kinematic equation. So you have S is equals to UT plus half AT square. Alright, as you can see, kita ada equal dekat sini, and this part here kita panggil left hand side of an equation, and this part here kita panggil right hand side of an equation. Alright, so before we literally look into this equation, let us first identify the term. Kita kenal tak semua term-term dekat sini? Okay, given here S ni adalah displacement, and then you have U multiply with T. U here is the symbol for velocity, which is the initial velocity lah, to be more specific. And then kita ada T here. T adalah time, masa, plus with half. Half is just a number here. A adalah acceleration kita, and then T square is coming back to the time here. Okay, so kita dah identify semua term yang present dekat sini. Kita kenal semua term dekat sini. So now we are going to check the homogeneous. So kita nak check whether this equation is homogeneous ataupun tidak. Homogeneous or not. Okay, kita nak check dia homogeneous ataupun tidak. So what are you going to do is you're going to split the equation into left hand side and right hand side. So dekat left hand side kita ada S lah kan. Dekat right hand side kita ada UT plus half AT square. This is what you have. However, when you look at your right hand side dekat sini, bahagian kanan sini, fokus dekat bahagian kanan sini. Bahagian kanan ini kita ada two parts. Okay, kenapa kita ada two parts? Anytime you encounter the function addition ataupun subtraction, dia akan immediately chunk your equation into parts. Okay, so kalau kita tengok dekat sini, kita ada tambah, kita ada proses penambahan dekat sini pada equation di belah kanan. Okay, so this split your equation. Dia pecahkan equation kita, dia pecahkan kita punya, yelah betul lah, expression dekat sini sebagai dua part. So you're going to have UT here as part 1 and half AT square as part 2 dekat sini. Alright, so for your right hand side kita ada two parts, for left hand side kita ada satu part sahaja, which is S only. So now we are going to look at the dimension. So the first step here, you focus on the dimension on left hand side. So untuk dimension on left hand side, apa yang kita ada dekat sini adalah you have displacement. So you write the dimension of displacement. Dimension of displacement akan sama dengan displacement adalah jarak, betul tak? Jarak kita associate dengan length, panjang. So the symbol yang kita akan tulis dekat sini adalah L sajalah. So this is the dimension that you manage to get for your left hand side. As simple as that. Settle. Habis. Now let us look at the dimension of the right hand side. This is the second part. Second step kamu. Dimension on right hand side. So dekat right hand side kita ada dua part. Part 1 dan juga part 2. So kita akan fokus pada part 1 dulu. Okay, part 1, dimension on the right hand side. For part 1 kita ada U dengan T. So tulis dimension U dengan T. Okay, U dengan T ini adalah hasil darab U darab dengan T. Initial velocity multiply with the time here. So what are we going to do is we're going to separate this dimension into 2 dimension. Kita akan ada U dan juga T. Okay, you're going to write them separately dekat sini. So U adalah velocity. Velocity here comes from, macam kita ada bincang tadi dekat atas, kita derive velocity adalah, this is your velocity. What do you get for your velocity here? LT negative 1. So saya nak pinjam terus daripada atas untuk jimatkan masa. So what I get for my U here, the dimension for U here is displacement over time. So I get LT negative 1. And then T adalah time lah kan, T juga, simbol dia adalah T. So I'm going to simplify this. T negative 1 multiply with T, we cancel each other, you end up with L sahaja. So on your right hand side for the first part, you end up with L. Dimension kamu jumpa adalah L sahaja. Now we're going to look at the second part here. For your second part, what you have here is half AT square. So kita tulis dimension dia. So what are we going to do adalah kita nak tulis dimension dia secara berasingan macam kita buat untuk UT tadi. However, what you have here in this equation, you have a half here. Kita ada half dekat sini. This half is dimensionless. Tak ada dimension. No dimension. Kenapa? As I've mentioned earlier dekat atas tadi tu, saya cakap numbers does not have any dimension. So apa kita boleh buat adalah kita boleh ignore dia. Alright, you can write, tak ada masalah, tapi in the end dia tak membawa apa-apa maksud, so kita boleh abaikan. So dia akan, kita ada half A T square kena tulis, power wajib tulis, power kena ada, power kita tak boleh halang, kita tak boleh eliminate, power tak boleh eliminate. Half ni saya boleh eliminate, half has no dimension, so saya akan ignore dia. So I'm going to proceed with A dimension dengan T square punya dimension. This is what I end up with for the second part. So A dekat sini adalah acceleration, and we know acceleration here, formula for acceleration adalah velocity over time. Okay, velocity over time, and dimension untuk velocity kita dah dapat tadi daripada sini. Saya boleh ambil velocity LT negative 1, ataupun dekat atas tadi kita dah buat LT negative 1 adalah dimension for velocity here. So I'm gonna just reuse. So saya nak jadikan dia terus dimension. Kita ada LT negative 1 dekat sini, and then over time, so I'm going to end up with LT negative 2, negative 1 divide with 1, kita akan dapat negative 2. So kita dapat LT negative 2 here. So my dimension for acceleration adalah LT negative 2 darab dengan T dekat sini di-squarekan. So your T here, it has a square. So dimension T kamu dengan square dekat sini, kena ada square. So we're going to simplify this. LT negative 2 T square, you end up with L sahaja. And as you can see, right hand side kamu ada part 1 dan juga part 2. Kedua-dua part 1 dan part 2 mempunyai dimension yang sama. L is equals to L. Maksudnya, your dimension on the right is the same here, L and L. And you can see that dimension on the left hand side is also L. So which leads to the conclusion that the dimension on the left hand side is equals to all the dimension on the right hand side. Dengar, saya tekankan pada perkataan all the dimension on the right hand side. Sebab dekat right hand side kita ada dua part. Kedua-dua part itu memberi dimension yang sama. So we can conclude that sekarang dimension on the right dua-dua sama dan juga sama dengan left hand side. Maka this equation kita cakap homogeneous ataupun dimensionally homogeneous, ataupun kita cakap dimensionally correct. Okay, so this equation yang dia bagi tadi S is equals to UT plus half AT square is homogeneous, dimensionally correct. Okay, if the term in an equation have different dimension, contoh any of the term tadi itu mempunyai dimension yang berlainan. Let's say lah kita tukar soalan, kita tukar, lepas tu dimension untuk first part from your right hand side ni kamu dapat LT negative 1, contoh So as you can see, your LT negative 1 ini tak sama dengan L for the second part of your right hand side punya. So the right hand side sesama mereka dah tak sama, and then obviously it is not going to be the same with the left hand side. Therefore, at this particular point, bila kita ada difference in the dimension, maka this equation is not homogeneous. Equation incorrect. Bila equation itu tak homogeneous, automatically dia jadi incorrect. Okay. However, kena remember, kalaulah kita dapat dimensional yang homogeneous, kalau dia dimensionally homogeneity sekalipun, dia tidak memberi 100% keyakinan ataupun it does not 100% confirm that the equation is correct. Boleh jadi awak dapat equation itu dimensionally correct. Okay? However, the equation can be incorrect. Dia akan wujud sebab dua situasi, iaitu the value of non-dimensional, contohnya adalah numbers, constant yang ada dalam equation itu salah. Kalau constant itu salah, contoh macam kita ambil equation tadi, S is equals to UT plus half AT square. Ini adalah satu equation yang betul-betul wujud dalam chapter 2. Let's say if I change this equation into S is equals to UT plus 3 AT square, and saya nak cari homogeneity dia, I'm going to end up with it is going to be homogeneous. Okay, dia akan jadi dimensionally correct. However, dia adalah satu equation yang salah sebab constant yang kita guna dekat sini salah. Okay, so boleh jadi equation itu mempunyai dimensionally correct ataupun homogeneous, tetapi equation itu boleh jadi salah disebabkan constant yang kita guna itu salah, ataupun boleh jadi equation itu incomplete. Maksudnya dia tak letak langsung constant dekat sini, dia jadi UT plus AT square. Still kita akan dapat homogeneous, tetapi secara tengok pada equationnya, dia memang salah lah sebab equation ini tak wujud. Equation yang wujud adalah kena tambah dengan half AT square. Alright, so remember, bear in your mind, to get a homogeneous equation, left hand side kena sama dengan right hand side. Kena sama, kiri kanan kena sama. Kiri kanan sama, dia homogeneous. Kalau kiri dengan kanan tak sama, kita dapat term yang berlainan, dia bukan homogeneous, maka equation dia pun lah automatically salah. Okay, equation dia pun automatically salah. Tetapi bila kita dapat kiri sama dengan kanan, dia homogeneous, tak semestinya equation dia betul. Boleh jadi kita tertinggal sesuatu atau kita punya constant salah, boleh jadi equation itu salah. So untuk dapat lebih banyak kepastian whether the equation is correct or not, you have to carry out an experiment to investigate the relationship between the variables in the equation, basically lah. Itu cara yang paling tepat. However, dari segi dimensional analysis, kita masih boleh dapatkan homogeneity. Okay, so this is what the principle of homogeneity is all about. This is our third learning outcome, basically, to verify the homogeneity of equation using dimensional analysis. So kita verify homogeneity of an equation, homogeneous ataupun tidak, menggunakan kaedah dimensional analysis. Dimensional analysis adalah apa? Left hand side sama dengan right hand side lah. Dimension kiri sama dengan dimension kanan, homogeneous. Kalau tak sama, non-homogeneous. Okay, if you have any question, just text me ataupun boleh raiskan dalam grup kelas kita, boleh tanya saya. Okay, itu saja untuk